So we're going to continue our work with hypothesis test with problem number 17. When 40 people used Weight Watchers diet for 1 year, their mean weight loss was 3 pounds, and the standard deviation was 4.9 pounds. Use a 1% significance level to test a claim that the mean weight loss is greater than 0. Based on these results, does the diet appear to have statistical significance? Does it appear to have practical significance? So those are two different questions. Well, let's start with this part right here. I want to test a claim that the mean weight loss is greater than 0. So let's put that down as our original claim. And that original claim is that mu is greater than 0. For that original claim, or with that original claim, we can set up our null and alternative hypothesis. So that's going to be our very famous step 1 here. Step 2, of course, is deciding what alpha is. Which hypothesis is mu greater than 0 going to go in?
Alternative.
Thank you, Jada. The alternative, so mu is greater than 0. And what's that put in the null hypothesis?
Less than or equal 0.
Well done. Mu is less than or equal to 0. Now, in my math lab, your choice will probably be mu equals 0. That's okay. I like this, as I said before. For alpha, we're going to do this test at the 0.01 significance level. So alpha is 0.01. For step 3, if we look back at our handout here, step 3 is going to be entering in our data. Now, the nice thing about this test, or this problem, is that as far as inputting our data, we've got summary statistics. We don't have to type in a lot of data into StatDisk or anything like that. So step 3, I'm just going to write down the summary statistics I need from this problem. So we've got n equals 40. I'll write down that. The mean is 3 pounds, 3.0, and the standard deviation is 4.9. So these are the summary statistics that I need. Note that for this data, I'm using X bar and S because those are your sample statistics. In particular, X bar is talking about the sample mean. You don't want to use mu there, all right? Mu is for the population mean. That's what we're testing the claim on, is the population mean. What would happen if everybody was tested on the Weight Watchers diet? That brings us to step 4, where we're going to try and get the p-value. Now, to get the p-value, we're going to put this information into StatDisk. Now, fortunately, our assumptions, at least the ones we can check, are met because we have a large enough sample size. 40 is greater than 30, and our assumptions require that either the population is normally distributed or the sample size is greater than 30, n is greater than 30. So we're okay there. We don't know what sigma is, so again, we're okay there. Step 4, now let me work my way back over to StatDisk. The analysis menu is going to get a lot done for you in StatDisk. Here we want to pick the analysis menu, then hypothesis testing, and then mean 1 sample. There's 2 other things that involve the mean, but that would involve 2 different samples. You've got a choice between use data and summary statistics. Since we have the summary statistics, we'll stick here. The first thing we should adjust, though, is the alternative hypothesis. You've got 2 choices. The mean is not equal to the claim mean is greater than the claim mean, or mean is less than the claim mean. Which one of these is the correct one? 1, 2, or 3?
2.
Good. 2. Significance level we wanted is 0.01. The claimed mean, where am I going to get the claimed mean? Where's that coming from?
Is that from your original claim?
Yeah, it's from your hypothesis. So the claimed mean is 0. Do I know the population standard deviation? No.
No.
If you look at what we've got the sample standard deviation. That's not sigma. They would have to give you sigma, all right? This just comes from your sample of 40 subjects. So the sample size is 40. We're going to leave the sample standard or the population standard deviation, we're going to leave it as is. The sample mean was 3. Sample standard deviation was 4.9. And let it rip. So we get a t-test. T is, our test statistics is 3.8. But this is what we really need, the p-value. P-value is 0.00020. Nice. Is everyone able to get that p-value from this?
Yes.
Okay. So that brings us to step 5. Step 5, want to compare your p-value to alpha. Our p-value was 0.00020. Alpha was 0.01. So our p-value is less than alpha. What's that say we're going to do with our null hypothesis?
We're going to reject it, correct?
Perfect. Reject H naught. If the p-value is low, H naught must go. So we're going to get rid of that. And that's going to bring us up to step 6, where we got to state our conclusion in words. So let's take a look at step 6. And I got to go back here. See if you can't figure out which one of these conclusions I should use, A, B, C, or D. And I'll give you a quick look back. Our original claim was that mu was greater than 0. So keep in mind your original claim as you work your way through this.
Would it be C?
C. Yes, I think so.
You got to vote for C, a couple of votes for C.
C.
I agree, it's C.
D.
A.
All right. A. Wow, our votes are all over the map. But that's good. Diversity is a good thing. Let's work it through together. So our original claim was that mu was greater than 0. Does that contain the condition of equality?
No.
No.
No. So we got to follow the downward branch. So that's right here. Did we reject H naught?
Yes.
Yeah, so that puts us right here for C. So we're going to use C to help state our conclusion. The sample data support the claim that, and then we're going to put the original claim in words. Sample data support the claim that the mean weight loss is greater than 0. Okay. Looks good. There's a couple other questions to answer on this, but I'll let you copy down the conclusion here first. Are we okay with our conclusion?
Yes.
Thank you. Let's look back now at the last couple questions here. Based on the result, does the diet appear to have statistical significance? What do you think? Was there a statistically significant result here as far as the claim is concerned? Did people lose more than 0 pounds?
Yes.
Yeah, we rejected the null hypothesis that there was no weight loss. We rejected the possibility that mu equals 0. Now, the question is, does the diet appear to have practical significance? Well, I guess you can judge that in 2 ways. So one way to judge it is this right here. After a year, the mean weight loss was 3 pounds. Are you going to be happy losing 3 pounds after a year's worth of work?
Nope.
No.
No, I wouldn't anyways. And I think I've said it before. You can put on 2 or 3 pounds by eating a really salty meal because you'll absorb a lot of water. So that's not a lot. Now we can see some more about that if you actually looked at the output from StatDisk. So let's see here. One of the nice things that the output from StatDisk gives you is a confidence interval. So it's going to give me 98% confident that the true mean weight loss is between 1 pound and a little bit less than 5 pounds. So, I mean, on the upper end of things, 5 pounds sounds better, but still, after 1 year, I'm thinking that most people would want to lose more than that in 1 year. Does this confidence interval match our decision to reject H0? Well, let's look back at our null and alternative hypothesis. You know what, let me just write down the confidence interval. Well, it was what, between 1.2 and 4.8? Something like that. 1.2 is less than mu, it's less than 4.8. Does this match our decision to reject H0?
Can we say yes because 0 is not included?
Perfect. Exactly right. Our null hypothesis includes the possibility that mu is 0. So if our confidence interval contains 0, we shouldn't be rejecting the null hypothesis. Because one of the possibilities then would be that, oh, okay, mu equals 0. If that was in your confidence interval, you shouldn't be rejecting H0. But because our confidence interval does not contain mu equals 0, this matches our decision to reject H0. So yeah, they go together very nicely. Any questions on that one? All right. Well, I think that's good for section 8.3.